Hi and welcome to this Plus4 engineering tutorial. This is going to be number 1 in a series looking at a Lexus 3UZ engine transplant into a Mark II MX-5. A lot of what you're going to see today will be applicable to 1UZ engines as well as other MX-5s though. And in fact, a lot of the general principles we'll follow can be applied to most engine conversions. I will be assuming though that you have some working knowledge of cars and working on cars. For you, perhaps this is the next logical step in your automotive evolution. If you haven't wielded a spanner in anger before, then this probably isn't for you, but we do hope you'll enjoy watching anyway. So, what we're going to look at today is getting this engine running in isolation, so that when you pull it out, all you'll need to add is 12 volts and fuel. This is a modern electronically controlled unit, so this is going to require a reasonable amount of wiring, but all the parts you need are in there. Ignore the internet myths. These engines run really well on a stock ECU alone, even without the auto gearbox. But before we start, I really need to make it clear, this is not going to be a step-by-step guide as to what wire goes where. There are simply too many variations between donor cars of different years and different models. It would be pretty much impossible, and not to mention tedious, to try and describe every installation. However, by the end of this tutorial, you should have enough information to at least begin tackling your own conversion. Okay, so you're going to need some tools. For this part, you won't need that many. Some decent side cutters for stripping out the wires that you don't need. Some wire strippers and some electrical tape. Don't worry, it's not a bodge job, and later we will do a proper wiring job with solder and heat shrink. But for now, we simply want to get the engine running before we pull it out and scrap the rest. If this is all new to you, I can highly recommend a label printer. You can get away with a tape and a Sharpie, but don't underestimate how many labels you're going to need, how long you're going to need them for, and how confident you'll need to be about what they say. The labels that this thing produces are durable, solvent resistant, legible, tidy, and easy to produce en masse. Another thing you might give consideration to is some diagnostic software, something that plugs into a USB port. eBay's got a range on offer, and a quick Google will help you find the right tool for your engine. If the engine's a runner already and the donor drive's okay, you can possibly get away without it. But if you need to diagnose problems, it will save a lot of head scratching down the ride. This is particularly true if the engine is no longer in the donor. And wiring diagrams. You can find these on the web on some of the forums if you have the time to search and know where to look. Alternatively, you can save yourself a load of effort and just buy one online. They're quite expensive for what they are, £60 to £100, but it's a bargain in terms of the hassle it'll save you. But be warned, even the manufacturer's workshop manuals can be wrong. Sometimes it's just wire colours, but I have found pins that are wrong or apparently connected to 2 different sensors. I'd also recommend getting a decent notebook, something that you can take notes in and refer back to later. And use internet forums. There are a few, and some of them don't suffer fools, so be careful of the questions that you ask. But alternatively, if you get really stuck, contact us here at Plus4 Engineering. We're fairly friendly and we'll see how we can help. Finally, just a bit of confidence. Don't underestimate what you can do. If you're generally handy with cars, you'll be surprised just how much you know already. It's all there. Your donor has all the pieces that you need, and once you've done it, it'll all make a lot of sense. Okay, so before you start on this, you need to think about your environment. If you can get access to a half-decent garage or workshop, then you have the luxury of downing your tools at the end of the day. If you choose to work outside, you'll be exposed to the elements, you'll lose the light in the evenings, and of course you'll need to secure everything at the end of every day. That said, getting the engine running on its own is certainly doable outside, and you don't need to worry about the threat of carbon monoxide poisoning either. So, once you've decided where you're going to do your work, the first job is to take the bonnet off and get it out of the way. You're going to have to remove the bonnet anyway, just for getting the engine out, so getting some light and space in there will be helpful. Next, clear as much stuff from the engine bay as possible. Bits of trim, engine covers, under trays and so on. Nothing that's mechanical or electrical, but things that are just going to improve your access. Then you need to locate the ECU. Using Google is probably a good starting point. Depending on your donor, it could be in a different location to this car. Likely places are going to be in the dash or in the footwells. Now the GS430 I have here today has the ECU in the engine bay. I've removed all the housing that the ECU sits in, and this improves access to the wiring. So let's have a look in our donor. As you can see, I'm well underway and I'm pretty much ready to pull the engine out. What you can see looks like a terrifying amount of wiring, but don't be put off. What we're looking at this point is what we can trim out of the loom whilst maintaining a running engine. One of the first things to identify is what you're going to need from the donor. Obviously, there's an engine and there's an ECU, but there are a few other things that you might want to consider as well. Drive-by-wire throttle. This car's got a potentiometer on the accelerator pedal, so we'll need to keep that. The immobiliser system. The ECU on this engine won't function without the corresponding key and amplifier. Then there's the OBD2 port from inside the cabin. The engine will run without it, but having it available and wired up correctly means you can diagnose the engine more easily. Here you can see 5 plugs running into the ECU. I've identified these in the wiring manual and I've labelled them up accordingly. For easy reference, I've also added some copies of the plug layouts so that I can identify pins. You'll see that some of these plugs, these 3 here, run directly through this loom and into the engine. For now, we're not going to worry about labelling those up. We have no real immediate need to disconnect them, although some will ultimately run to things like the gearbox, which we might not need. What we are going to focus on is these 2 plugs here, where most of the wiring disappears down into the rest of the vehicle loom. On these plugs, I've labelled the ones that I know are needed. Hopefully the benefit of a label printer is now becoming apparent. How will you know which ones are required and which ones aren't? Well, study the wiring manual. These are generally going to be things like ground wires, battery 12 volt, ignition 12 volt, O2 sensors, and also the wiring to the bits from the cabin we've identified as being needed. Drive-by-wire throttle, OBD2 port, immobiliser system and starter circuit. There's also some wires that feed a separate fuel pump ECU, and we will come on to that later. I recommend that you take this very slowly. Work through each system and identify each wire in turn. Regularly fire at the engine to make sure that you've not trimmed something vital. If you're not sure about cutting wires, label each side of the cut. That way you can find your way back to where you started. Leave plenty of length when cutting wires. Tape up loose ends. Try to cut on the other side of the plug. This allows you to use the plugs in your own installation. Cut away the minimum you have to get the engine out. I've identified all the feeds which require 12 volts or grounding. I've isolated the system from the fuel pump ECU and I'm driving it from the battery. The fuel pump ECU in this vehicle is there simply to reduce noise and load on the pump at idle, so the pump will run fine on 12 volts for now. One thing to note though is that the coil packs don't draw their current from the ECU. You'll need to locate the specific wire in the engine loom and feed that 12 volts as well. Everything else that ties into the body loom has been cut. So let's see if our engine runs independently. So, we've got a running engine and it's time to pull it out. The rest of this is spanner monkeying, so I'm not going to show how to undo bolts. There's plenty of information on the internet without me adding to it. I do have a few final thoughts for you though. First, plastic pipe cutters. These are from a plumber's merchant and they're intended for cutting plastic waste pipe, but they're brilliant for cutting rubber hoses as well. They ratchet down and safely sever pipes in hard to get to places. Most of the hoses that need to be disconnected won't be required, so you can cut them and save yourself an awful lot of hassle. Second, be wary, you've now got an auto which will start regardless of the gear that it's in. Autos will push around in gear like a manual in neutral. Don't be tempted to proudly show off your running engine if you don't know which gear it's in for sure. Trust me, I've made that mistake and it scares the crap out of you. Finally, you're going to have to deal with the aircon system. Venting into the atmosphere is illegal, it's dangerous and it's not very environmentally friendly. Your local aircon regasser will be able to drain the system for you. So I'll leave you to get on with your project whilst I get on with mine. And the next time I see you, we should both have engines on the floor. In the meantime, don't forget to check in on us online. plus4engineering.com, Facebook/plus4engineering, Twitter @plus4e, that's PLUS4E, And you can also find us on our YouTube channel.